So thank you very much for attending this talk. It's one of the latest talks in the session today, and probably everybody is a little bit feeling the time to go home and chill. But we can have a very a nice conversation. So feel free to interrupt me anytime. This is going to be a relatively technical talk. And I'm going to assume that people that is interested in listening about this already knows the general concept of media mix modeling and why they're important and how you do use them in the industry. So I'm going to skip a little bit on the details to really focus on the technology that we are using and how we evaluate it. But just to make the point, let me just say that it's a framework that allows you to do media measurements. Now, in the US, there is every year about $100 billion deployed in marketing. So you can imagine that this is a big industry. And it's a widespread challenge. Actually, there is a Gartner survey, which was done in May, that basically measured that 61% of CMOs in the US were either thinking about implementing a media mix model or they were actively working on this. And it's a decision that, of course, it's high stakes because you deploy a lot of marketing budgets. So it's the framework that allows you to optimize that budgets. You can get efficiencies that are in the range of 10 to 15% in your CAC if you do it right. And there are a lot of vendors that offers you ecosystems of tools out of the box. Now, what we are going to focus on today is the two most well-known frameworks that are open source for implementing media mix models. And if you look online, there is going to be 1 million different blogs that really do a high-level feature comparison between the two. But to my experience, most of the people that actually wrote this blog, they actually never used it. It's marketing material. And they are not data scientists that have really measured what these two frameworks, how the two frameworks differ from each other. So just to make the high-level points, so the frameworks that are available in the industry by number of downloads are basically these ones. So PyMC-Marketing, Meridian, and Orbit to some extent, which was built by Uber, are the three most used. There is another framework which is called Robin, which was built by Meta. It's not very popular in the Python community, although it is very popular in the R community. So there is some Python bindings, but they're not excellent. And so people who want to use Robin, which is a completely different framework, they tend to use it in R. Now, PyMC-Marketing, Google Meridian, and Uber, they are the instance of the same type of model, which is Bayesian models. And the reason why Bayesian models are used in the industry is because they have a lot of nice properties when you work with small data sets. The most important one is that you can set priors. So if you have even a very small amount of data points, they can actually recover good signals because the priors allow you to guide the fit of the model. Now, before we go into that, full disclosure, this is me. As was said, I'm a partner at PyMC Labs. So, of course, we are the people who built PyMC Marketing. So you may think that this is a bit of a biased evaluation. So, of course, as in every evaluation, there are some assumptions we make. But the entire evaluation is open source. So you can check the code behind it at the repository you will see at the end of the talk. I'm going to give you the link. And the methodology is fully transparent. So you can wanted to make it as much as an unbiased benchmark as possible. Although, of course, in the way we generate the data, in the way we set the priors for the models and so on, there are some assumptions from best practices we have learned throughout the years while working in this industry. And so that gets encoded in the way we generate the data sets. The two libraries that are the most used that we're going to evaluate today are PyMC-Marketing and Meridian. So PyMC-Marketing is the incumbent. By the number of downloads, is about double the number of downloads of Meridian, although Meridian, which is pushed by Google, has getting a lot of adoptions. And to some extent, they're doing a lot of things right. They created a partnership program. They have a very, very good documentation. So Google is putting a lot of resources in training media agencies to use these frameworks because Google is a large publishers and media network. And of course, what these media mix models do right is that they allow you to measure the incrementality of especially view-through channels. And now Google is pushing beyond what is traditional search in things like YouTube and rich media frequency channels, which can be measured effectively with frameworks like media mix modeling. And that's why Google is interested in investing in this ecosystem of open source tooling, and they pushed out these libraries. Feature-wise, there is a huge list of features. They're very similar to each other. The gist high level, and you actually have some decent blogs online on the different features. PyMC marketing is generally more flexible. It allows you to build more complex models because it gives you building blocks, while Meridian has a bit more simplified, higher level API. Two notable differences. PyMC marketing allows you to set time varying coefficients. We're not going to talk about that during this talk, but it's an advanced feature that is important in many different scenarios. So if you fit a model, you typically assume that the ROI you get from this channel is stable through time. However, PyMC marketing doesn't, if you don't want to have that assumption, it doesn't make that assumption. It can tell you that the efficiency of a particular channel changes through time. And the other one is that through PyMC marketing has multiple sampling backends. And so when you fit, the process of fitting a Bayesian model is called sampling. You use an algorithm which is called HMC, Hamiltonian Monte Carlo. And you can have multiple backends with PyMC marketing to do that are optimized for specific instances of numerical computations, while Meridian uses TensorFlow probability, which is a framework that comes with the library TensorFlow, which used to be a library for deep learning put out by Google. So the way that we are basically doing this is, the way this model works is that you get some historical spend and an outcome that you want to predict, which could be conversions, revenue, signups. You can add control variable. You encode some behavior and some knowledge into these models by saying, for example, that my estimated ROI for this channel is between X and Y, based on what my marketing channels believe. And then you fit the model, a model that can have interpretable but complex nonlinear responses like, for example, it can say that channels have diminishing returns. The more you spend, the least signals you get, the least ROI you get. And this is, it's a well-known fact in marketing because you saturate your audience. Or it can have things like carryover effects. So you can say, what I spend today in marketing will actually have an impact over the next few months. And the last one is, they can make these complex models very complex, is hierarchical structure. You can say, for example, that my data set is organized in countries, and then states, and then DMAs and regions within that. And the reason you want to do that is because maybe you don't have enough data at the region level, but you have enough data at the state level, if you have more history, and then you can pool the coefficients across the different level of the hierarchy to get a better fit. The traditional way of evaluating Bayesian models is the following. So these are fully generative models. You can generate an output of prediction. So you can compare against some ground truth. And the way you do is that you basically encode in your model specific assumption, you simulate some data, then you refit the model on the simulated data, and you see whether you can recover the parameters of the original model that had generated the data. So rather than thinking about in the traditional sense of machine learning or predictive analytics, where you want to get the best accuracy, the purpose of this model is really to recover some unknown parameters. And the parameters we want to recover in this case is the unknown ROI of each channel. My predictive accuracy measure how accurate I am in predicting sales of revenue. My parameters tells me how this sales and revenue is generated by some unknown process underlying, which is the ROI of these channels. I hope that everything is clear. This was the crash course in media mix modeling. So how do we, can we evaluate at scale whether these models are accurate in reconstructing this ROI? So we generate simulated data based on the configuration of this model. So our experiment is going to be, well, based on my assumption of how the model works, I generated some data sets that's realistic, that looks like companies up in the wild, spending money in marketing and generating revenue. And I'm going to try to reconstruct the ROI of the channels that generated that specific outcome by fitting the model. And I'm just going to see which model is the best in reconstructing these data. And what we do is that we generated data sets of different types of complexity to really see how this framework scales across larger and larger and more complicated data sets. And we start from a company that you could consider a startup. So this is maybe have a couple of years of data, operating in one geography. It has maybe 4 marketing channels. Maybe they have Facebook, search, Instagram, so it's digital stuff. And then we increase. So we go towards a more mature companies that maybe operate in 8 geo. They have 8 channels. And as you can see here, the dataset size scales across 2 dimensions. One dimension is the number of columns in the datasets. That's typically related to the number of channels the company is operating. And the other one is the number of rows. Now here, there are still 2 years of data. And the number of rows happens to increase because you have more geos. And so you have 2 years of data for all the geos that you have and for all the channels that you have. So this can get really, really actually decently sized. We're not talking about still yet about big data, of course. We're still talking about something, a relatively small data problem, but of a decent size for enterprise. For example, here, it's a data set that has about 10,000 rows and 43 columns. Now, for a traditional ML model, like a gradient boosting model, this would be like a breeze. Now, for these Bayesian models are very intensive when you're actually fitting them, because the outcome is not really to get the best fit out of it, but to reconstruct unknown hidden parameters with the confidence interval. So what you're going to get out an entire probability distribution of possible hidden parameters. And to get that, you need to do sampling. And so there is no other way of mathematically to do that. So what you're going to test is across these different 4 scales to see how these libraries can be adapted to a client with a startup towards an enterprise. We're going to compare them across computational efficiency, which is in the speed of fitting these models, predictive accuracy, which, as we said, is not the goal, but is something you need to take care of or like try to understand. This mostly tells you not whether the model is good about making predictions of the target variable, but whether the model is flexible enough in terms of parameterizations to fit the data. And that's why, for the moment, we just restricted this to look at the in-sample accuracy. And so in-sample accuracy doesn't tell you anything about how you're going to be good at making out-of-sample predictions, as every good data scientist knows. But what it does, it tells you whether the model can actually reconstruct the data. And then the last one is, of course, the recovery of these hidden contributions that are the ROI of the different channels. And the data was, the last thing I should say is that was very realistic. So these channels had very spiky behaviors. Everybody has worked with marketing data. They know that the marketing data channels are very correlated. So people tend to spend within the same period across different channels, around Christmas, for example, if you are in e-commerce, or around Black Friday. And they have very spiky behavior. For example, on TV, you may want to do media campaigns in specific periods, then you go to 0. So these are very hard scenarios because everything is correlated with everything else. And everybody has done linear regressions where you have correlated variables. What tends to happen is that you get coefficients that are meaningless because like the correlations is creating situations where different things are confounded with each other. So let's look at speed. So the way we're going to measure speed is in terms of what is called the number of effective sample size per second. So this is the actual right way of measuring speed of a Bayesian framework. When you're sampling data for a Hamiltonian Monte Carlo, what happens is that you maybe retrieve 100 samples, but only the ones that the sampler thinks are actually, according to the underlying distributions, they become valid samples. They can actually give you information. The other ones, they get always discarded. So when people fit these models, they often say, I want to fit by extracting 2,000, 4,000 samples. But what you should actually look at is how many effective samples you get out of the distribution that they are on. Because if you compute the parameters based on samples of 10 effective samples versus having 100 effective samples, you get a much more precise estimations of the underlying distributions. And here you see for the scale-up data, PyMC-Marketing with the backend NumPy versus other different backends, so the default one, and versus Meridian. So you can see that PyMC-Marketing with NumPy, which is this backend, is about twice as effective, or it has twice the speed, which is a thing we see across all the other data sets as well. And on the enterprise data, which is the largest one, Meridian doesn't converge. So it just tells you, hey, I can't fit this stuff because it's just too big for me. While PyMC-Marketing, although it's very slow, manages to complete the fit. Now, what I should say is that when you operate at the level of an enterprise data set, it could be a company like a Colgate, Palmolive, or a Coke, or very large companies, making examples, you will not run the models as they're running this benchmark as defaults. You will do a lot of tricks to reparameterize your models so that they can actually tackle that size of the data sets. And you will write very custom stuff in these frameworks. So here the question that we're going to highlight is whether when I run these frameworks with mostly default parameters, and to run these evaluations, we used default parameters in most cases for the two libraries, whether they can complete the fit. I'm sure that there is also, perhaps, I'm actually not sure about that, but perhaps maybe there is a way to run Meridian on enterprise level data with some hacks and configurations, but with default parameters, it just doesn't work out of the box. The other one is predictive metrics, which, as I said, are good to look at. As areas you can see, they both achieve a decent fit. PyMC-Marketing fits a little bit better across the board in this instance. Now, this was done with PyMC-Marketing version 0.14. And I forgot what this was the version of Meridian, but it was a couple of versions before. Now we're going to see an update on these results in the second part of the talk, which actually has a surprising take with the latest version of Meridian and the latest version of PyMC-Marketing. What you should look at is also this model, this parameter, which is called Darwin-Watson, which is a coefficient which is good when it's close to 2. And the farther is from 2, it tells you whether the residuals of the models are actually autocorrelated. And when the residual of the models are autocorrelated, that should ring you a flag, because that means that the model has some systematic bias and error. And so here, the fact that the Darby-Watson of PyMC marketing is at that range, it means that the model is kind of having uncorrelated errors. So it means that it makes errors at random, while Meridian doesn't make error at random. So there is some parts of the fit that just doesn't get right systematically. And so it means it's kind of missing a component. And we're going to see in a minute what that component that's missing is. But the thing that we should really look at is the reconstruction error. These we measure in two ways. We use this thing which is bias. So bias is the difference between the average signal of the ROI and the one that we get. So PyMC marketing has a lower bias, which is good. And here, the fact that it's negative, it tells you that it's overestimating a little bit the ROI of the channels. Sorry, it's underestimating a little bit the ROI of the channels. And then scaled RMSE is basically the RMSE of the channel scaled by the average of the channel ROI. And the reason why we use that is because the channel of the ROIs can get to 0 sometimes. So when it's 0, you don't want to explode. So that's why you use the scaled RMSE instead of MAPE. As you can see, is twice as accurate than Meridian. So generally, these are also, because you have Bayesian models, you can get also the confidence intervals on these error metrics. And you can see that not only the values of the averages of these metrics are better, but also the confidence interval of these metrics is better. So what does this mean? Let's look at these a little bit more qualitatively. So here you have the contribution of social media and the contribution of, these are two different channels. I'm not sure why they're called social media and email, sorry, for PyMC marketing and Meridian. So the black is the data line. The yellow and blue are the prediction and estimation of the models for these unknown hidden parameters. And as you can see here, PyMC marketing with NatPy is way closer to the actual data, while Meridian, in this case, is actually underestimating that peak of ROI. And here you can see here that you have a much larger confidence interval for Meridian.
Is the y-axis label at the lower left and the upper right swapped?
Yeah, probably. So this is PyMC marketing and Meridian for, yeah, so it has been swapped. Yeah. So I should mention that to make these slides look good, what I did is I gave it to Notebook-ML, and I said, make it look good with all the robots and stuff. And that's probably when it flipped this axis. So there may be other hallucinations like this one. Same thing for the email contributions. You can see here that Meridian didn't manage to get the email contributions at the peaks. Now, you may ask when these errors actually happened. So this is what we noted. There are two cases where errors happen from these models in the marketing data. One is that you have channels with spiky spend. And here you can see that on the first row, you have your spend pattern. On the second row, you have your contribution pattern, so the ROI in response of how much I spend, which is unknown, it's hidden. And the black line is the actual, and the blue line is the estimate from PyMC marketing, and the yellow line is the estimation from Meridian. As you can see here, PyMC marketing is underestimating systematically the truth, while Meridian is overestimating systematically the truth. But more interestingly, when there is a region of zero spend, like they correspond to where I don't have the vertical bars, you can see that Meridian thinks there is actually a response. So why is that the case? How can I spend zero in marketing but still have a contribution from the marketing channels? So that comes from the ad stock contributions, right? So the ad stock that I put into the model tells me there is a carryover effect of the marketing channels that propagates through time. And what's happening here is that PyMC-Marketing is estimating an ad stock that's a little bit more realistic, while Meridian is estimating an ad stock that's very long. And that carries over these bumps, the smooth over regions where there is no spend, and overestimate systematically those periods. Another thing that we notice is that the channels where you get most of the errors, and that creates a lot of convergence problems also in the solvers, and makes Meridian explode in this enterprise dataset and not come to an actual solutions, are situations where you have channels that are very close to saturations. So here the concept is, if you have a channels that it's not close to saturations, you have a good kind of linearish relationship between your variation in spend, which is measured across the x-axis here, and your variation in contributions from the channels. So they kind of move together. So you have enough wiggle room to really understand what the channel is doing. When the channel is close to saturations, as it happens here, I can change my spend, I can pulse my spend a lot in the marketing channels, but the response is always the same no matter what I do. And when that happens, the response is almost flat. And what happens is that it gets confounded with the baseline of the models. These models always have a baseline. And if you get confounded with the baselines, doesn't matter, you can exchange between the two, it gets the same fit, and the model gets confused. And this creates a lot of numerical errors, and it creates like a higher error in general of estimating the performance of these channels. So in general, these are common but very hard situations to solve that requires actually tightening your priors on the models. But these models were run with default priors, so we didn't go through this exercise, and that's why they get this relatively higher error. Now, since these came out, the two versions updated, and one of the reason why Meridian was creating that systematic autocorrelation errors was that they used the different ways of modeling seasonality. So in PyMC-Marketing, you have this concept of Fourier time series, where basically you decompose seasonality as a recurrent pattern that's modeled with Fourier modes. So it's basically a sum of sines and cosine waves. While in Meridian, you use splines. So the baseline can flex in any way, in any shape or form, but it cannot model periodic things. So which is a bit weird, but that's actually what's happening. So I see your reaction when we found out was also our reaction, but that's how it happens. Now, the problem is that the splines, they have a parameter which is called the number of knots, which is basically the number of points you can use to kind of create this thing that interpolates between points and how flexible you want to meet. So the more number of, the highest the number of knots, the more flexible is your model, which is great in some sense because you can model more complex behavior. But of course, you don't want too many points, otherwise you overfit. And we didn't know how to set these parameters, so at the beginning of the evaluations, in the first case, we left it to the default that was suggested by Meridians. Now, in these new versions, they introduced something which is called automated knot selection, which should magically find the number of knots that's appropriate for your data sets. And to some extent, it does. So what you see here is that the accuracy of Meridian actually went way higher. They have a better MAPE, and they have a better R-squared on the data set. So it's actually fitting better. You get a lot more flexibility. Remember, this is in-sample fit. It's not out-of-sample fit. It's in-sample fit because one of the disadvantages also of spline is that it's way harder to extend them to do out-of-sample predictions because you don't have this periodicity assumption. So you actually don't know how the spline is going to behave when you predict the future. So that's one of the drawbacks of using splines. but the fit in sample is way better. However, you still get this problem that there is something weird going on. And you see that from the Darwin-Watson statistics. So as you can see at PyMC-Marketing, the Darwin-Watson remains about the same as you scale the size of data sets, while for Meridian, Darwin-Watson, which is this number that should be close to 2, and the lower it gets, the worse it is telling you that there is still some missing component on this data as you scale up the data, because they're missing still this kind of seasonality. So it's fitting better, but structurally, conceptually, is not actually capturing the periodic effect that's been encoded in the data set. And the most important thing is that when you actually look at reconstruction error for the unknown parameters, well, nothing has actually changed. And so they actually still have a pretty bad reconstruction error. So here in these situations where these automated selections actually puts you in a kind of weird scenario where you, as a data scientist, you may have thought, oh, this model fits way better actually in sample. But what it's actually doing is actually dangerous because it's actually still creating a relatively high error rate in these unknown parameters. And if you hadn't done, if you are in a situation which is an actual situation where you don't have ground truth for your marketing ROI, because these are real data, so you don't know the ground truth, you're trying to estimate the ground truth, you are actually, you will not be able to realize this effect is actually happening. This is just an aside. Even with this automated spline, basically the performance in fitting, the fastness in fitting has not changed. Before I showed you just on the mature data set. Here you see for small growing and business, small business growing and medium, you see that even a smaller scale PyMC-Marketing with a different backend, it's called blackjacks, not Py, can be even like 20 times faster than Meridian in fitting. So what's our field guide to choose the different frameworks? So PyMC-Marketing gives you the flexibility with different backends to fit on the CPU. We haven't done the evaluation yet on the GPUs, which you could do, but on the CPUs at least, to fit as fast as you can different types of data sets. Different samplers work in different conditions of the data set better, so you should try a bunch of them, which one works better for your data set. Generally, NumPy tends to work the best at large scale. Blackjacks, NumPy works, and blackjacks work the best for smaller data sets. Then for global brands, unless you go on the GPU, which we haven't tried, whether Meridian works, you cannot really fit these large-scale models. Again, at the enterprise level, everything tends to be custom, just because for this type of models, you have a lot of data sets. And also, effectively, we always run this model with those clients on the GPU. We never run it. We rarely go on the CPU for those clients. And I mean, generally, our recommendation is if you only care about predictive accuracy, yes, you may want to look at Meridian. Otherwise, according to this benchmark, we didn't see any other specific reason to do that. Because from this benchmark, it appears that PyMC-Marketing has a faster allows you to faster iteration if it's faster, has more accurate attributions, and therefore it empowers you to have more robust decision making. Now, if you are interested in call bullshit on this, of course you can. We benchmarked this so that it's fully reproducible. So you can go on PyMC Labs, MMM parameter recovery, and unlike other vendors that they give you the benchmark for the evaluations, but they never give you the underlying data, you will find here the data generation script. You can find the configurations of the models. And so you will be able to replicate the full benchmark yourself and verify what I told you today. So thank you very much for listening to me.
Thank you so much, Luca. We have 5-ish minutes for questions.
Would there ever be a case in the, so you mentioned the DW score with Meridian is much worse. To me, it seems like there's a bit of an inherent conflict of interest of trusting like the biggest ad company to do your, the evaluation of your marketing strategy. And so do you ever see a case in which like Meridian is understating, or is it always overstating the performance and telling you spend more on Google Analytics?
Yeah. So let me see how I can respond to that in a way that's politically correct. So I do think Google went a long way because Meridian is fully open source. So if you don't trust the way that they implemented stuff, you can verify the code. Of course, there are design choices they have made that are very peculiar. For example, they have a couple of features which allows you to introduce reach and frequency channels, which allows you to basically, instead of inputting media spend, to input impressions. And that features is available for YouTube and a couple of other Google channels. Why? I don't know. I mean, like that's a design decision. The other one is the way they encode the priors. The average importance of the baseline is with the default priors, which you can change if you want to. But with the default priors is to push the baseline way lower than the default priors we encode. And now with that effect, of course, your marketing performance is going to be always a little bit more overestimated. For this benchmark, we actually corrected the priors. We made it the same across the two libraries because we didn't think it was fair to leave it at that level. It still comes up as overestimating a little bit, which I don't understand exactly why, but that's the result of the empirical benchmark. But generally, here is to say that in the way you build these models, of course, there are some beliefs that gets encoded in the way you build a library, although the entire library is open source, so you could call bullshit on them if you want to by checking their code.
Thank you, Luca. So as you mentioned, the Google Meridian doesn't have this time-varying covariates, but PyMC does. I'm wondering if you've ever worked with creative changes. So in other words, like the creative teams are always changing color schemes, graphics, language in the advertisements. But as data scientists doing mixed media, like, do you recommend we just say this is out of scope? Like if ROI is improving over time, can we really say it's because the brand team's doing a better job with the color and the design, or should we just say we can't attribute what this increase is?
No, I think it's actually fair to do that. And that's the reason why the time varying coefficients was built and was added as a feature into the model, is to measure situations where the performance of the channels improve over time because your team becomes better at doing creatives or doing micro optimizations across the audiences. And you actually see these weird patterns in data where, for example, the performance, we had the clients for which the performance of the channel at some period just went to 0, and then we asked what happened and say, hey, new head of marketing came in. I said, okay, that's a new head of marketing effect. So it actually does happen in these cases. Now, in practice, probably the first iteration of the model, you don't want to build that with time varying coefficients and get an average effect across time because those models are actually hard to fit. And you need to do a few tricks to make sure you fit them. And so the first implementation shouldn't probably have that, but it is really a very sound effect to encode.
Thank you so much, Luca. We have a 5-minute break right now, but I would encourage you to continue the conversation, possibly towards the hallway, and one more round of applause.
Thank you.